Hi everyone, today's video will be a bit different than normal. It's more maths than it is history. Don't worry, this is only a one-time thing. So a lot of people know that you can't twist just one corner, flip just one edge, or switch just two pieces on a cube. However, normally people actually know why that is. This video will be a relatively simple explanation of why. Firstly, corner orientation. Here we have a cube I prepared earlier. As you can see, the only stickers on the cube are the yellow and white stickers on the corners and centers. This will help us easily keep track of the orientation. If a yellow or white corner sticker is on a yellow or white face, then it's oriented. But what if it's not oriented? We need a way to keep track of that. Let's assign numbers to each of the three orientations. A 0 will mean the corner is oriented, a 1 will mean the corner is rotated clockwise, and a 2 will mean it's rotated anti-clockwise. Notice that if a corner is rotated 3 times, then it's the same as not being rotated at all, and so 3 equals 0. Also, 2 clockwise twists on the same corner is equivalent to 1 anti-clockwise twist. This is called modular arithmetic. Putting the numbers in a circle will make this clearer. Going clockwise one step around the circle is the same as a corner that's been rotated clockwise, and going clockwise 2 steps is the same as a corner that's been rotated anti-clockwise. If we look at all the corners and go around the circle depending on their twist, we'll see something interesting. If we list the orientation of all the corners on a solved cube, we would have 0, 0, 0, 0, 0, 0, 0, 0. Going around the circle, 0, 0, 0, 0, 0, 0, 0, 0, we obviously end up at 0. Turning the top or bottom faces has no effect on this, and neither does turning any of the side faces 180 degrees. If we turn a side face 90 degrees, we could list the corners like this: 0, 2, 1, 0, 0, 1, 2, 0. Going around the circle again, 0, 2, 1, 0, 0, 1, 2, 0, we end up at 0. This means that turning a face doesn't affect where we end up on the circle. Even if we completely scrambled the cube, it wouldn't matter. For example, this cube has just been completely randomly scrambled, and we have 1, 0, 0, 0, 1, 1, 2, 1. So if we go around the circle, 1, 0, 0, 0, 1, 1, 2, 1. We end up at 0 again. So we now know that all legal moves will end at 0 on the circle. However, if we twist just one corner, the situation changes. Now, we won't end at 0 on the circle. As a demonstration, 0, 0, 0, 0, 1, 1, 2, 1. 0, 0, 0, 0, 1, 1, 2, 1. We end at 2. And unless we manually twist that corner back, we will never reach 0 again. This shows that you can never just twist a single corner on the cube. Wow, that was a lot to take in. Don't worry, that was the hardest part. Breathe, get some water, and let's do part 2. Edge orientation. I have another cube here that has stickers on just the edge pieces. The orientation of edges is quite different to the orientation of corners. If a yellow or white edge sticker is on a yellow or white face, then it's oriented. However, if the edge is in the E slice, then the yellow or white sticker needs to be on the front or back faces. Any other case means the edge is oriented wrong. So what happens when we turn the sides? Well, the top, bottom, left, and right sides make no difference. They don't affect the orientation at all, and a 180-degree turn of the front or back sides don't make a difference either. If we turn the front or back 90 degrees, however, we see that it flips some edges. Specifically, it flips the 4 on that face and no others. Notice, 4 is an even number. This means that every time the cube is turned, an even number of edges will always be flipped, either 0 or 4. 0, 0, 4, 0, 0, 4, 4, 0, and so on. So no matter how you turn the cube, an even number of edges will always be flipped, never an odd number. As a demonstration, not flipped, not flipped, 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 flipped. 6 edges flipped. Flipped, 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 flipped. Again, 6 edges flipped. And we can keep going like this. As a result, you can never flip just one edge, because if you could, then an odd number of edges could be flipped, which we've just shown is impossible. Lastly, permutation. Here we have a cube with 8 numbered pieces. We can list these numbers by starting from the top left and going clockwise. If we rotate this face, then the list will change. Let's write it beside the first list and match the numbers up. You'll notice that the lines cross each other a number of times, 12 times to be exact. If we do a T-perm, then the list will be different again. Writing it down and matching the numbers up, the lines cross each other 8 times. These are both even numbers. With a bit of experimenting, we can see that any manipulation of the top layer and no other pieces will cause the lines to cross each other an even number of times. For example, this case. However, if just 2 pieces switch places, then the lines cross each other an odd number of times. This is why you can't switch just 2 pieces, because any legal moves will cause the lines to cross each other an even number of times. Okay, that was a lot, and it wasn't really related to history at all. Don't worry, the next video will be history, and it should be very interesting. See you then.